purpose of this video is to look at the idler gear and how that affects a simple gear train. So what we've got here is we've got an input gear which has got 80 teeth. Idler gear is the one that's always in the middle of the other two. That's got 10 teeth, and I've got an output, the driven gear, has got 40 teeth here. Now, if I was to consider, the purpose of the idler gear, first of all, is to make the input and output travel in the same direction. So if I show you there that the input is going to be travelling clockwise, that means that the idler gear is going to be travelling in an anti-clockwise direction, which means again that the output gear, so you can see the output gear and the input gear are travelling in the same direction, both travelling clockwise. If we also look at how that affects the speed, what we've got here, if I make a decision that the input is travelling at 1 rev per minute, the ratio 80 to 10, that's obviously going to be travelling 8 times faster. So that gear, the idler gear, will be travelling at 8 revs per minute. And then we've got a ratio of 4 here, so 10 teeth to 40 teeth, that's a ratio of 4, so it's going to be going 4 times slower. So the output gear will be travelling at 2 revs per minute. Now, I didn't need to do all those little steps to get to that output speed there, because the idler doesn't actually have any effect at all on the speed. If I take that gear out, if I was to take that gear and then squash the two gears together, I would have something more like looks over here. So I've got our 80 teeth and our 40 teeth gear together, and I've simply removed the idler. If I go back to that travelling at 1 rev per minute, we've then got 80 teeth to 40 teeth, which is a ratio of 2. So this is going to be going twice as fast. So 2 times 1 is obviously 2 revs per minute. So the purpose of the idler gear, as I say, is to change the direction, but it has no impact at all on the speed.